Hello everyone, I'm Harsh and I will walk you through our project NeuraNFT, an application that will store your AI in a decentralized way. So before starting any decentralized application, we have to authenticate it with the blockchain it's based on. And in our case, it's ICP. ICP provides a way to log in with or create internet identities that act as entities for the users using the decentralized application. In the backend, we initialize an auth client, which will redirect us to the ICP login portal for authentication. We are working in test mode, so we are using the testnet here. But if we were working on the mainnet, suppose, the login process would have been slightly different. So we will make an account here. After authentication, we will be redirected back to the main page, and then we will be able to see our account address here, meaning that we have been successfully authenticated. After authentication, we will see a drop bar showing NFT collection and an option to create NFT. I will click create to create new NFTs. I'll make a knowledge base having my resume as a reference. After it is created, we will see a success message on the top bar. We can see our created NFT on the collections page also. Now coming to the collections page, in order to chat with NFTs, we will have two options. The first one is through the application UI. The second is an API-based one. I will show you the UI option first. Here we have information about the NFT's model and its description. And once the model is loaded, we can chat with it. So as I uploaded my resume, I'll query. The query will be sent to the HPC nodes, which will send it to the model server, and the model server will respond to us. Now coming to the API part, when I click on the API button, the backend will generate an API key, which will be then passed to us. I will copy this API key at the endpoint and demonstrate the request on Python notebook. We can also use Perl or Terminal for this. I pasted the API key on the endpoint here. We have designated routes in the backend for API calls. On the first endpoint, the backend will verify the authenticity of the API key, and if it is authentic, it will return a GWT token with the URL where our base model is hosted. In the second endpoint, we will pass a query with the GWT token and the URL. If the GWT is verified, the model will give the response to the query. After giving a high-level explanation of the project, I will explain the whole architecture in detail. There are mainly two canisters in a typical React project. One is the front-end canister, which is mostly React-based, and the second is a back-end canister, which is made on Rust language. Coming to the data flow now, once the user enters NFT details, the backend canister will send a HTTPS request to the HPC nodes for vectorization of the data. We are using LangChain for generating the vector embeddings. The data is basically the RAG data, which is stored inside the NFT. Now, when the user initiates a chat for a particular data, the backend will again send HTTPS out calls to the HPC nodes, and the HPC nodes will then store these embeddings inside a session variable, thus making the retrieval process efficient. After the model is loaded and the user prompts a query, the queries will be routed to the HPC nodes, and after passing the token authentication check, it will be processed by the model to give an appropriate answer. Now, coming to the future scope of our project, the current architecture is a single HPC node architecture, which has limitations in terms of scalability, but it will be upgraded to a network of distributed HPC nodes, and gradually we aim to take the whole computation fully on chain in future. We also have plans to implement a marketplace for trading NFTs and create autonomous AI bots which can have self-learning capabilities. More details are available on our light paper. Lastly, I do a quick overview of our code base. As mentioned earlier, the smart contracts are written in Rust, which provides a fast runtime environment, which is crucial for our model's architecture. Here is the NFT smart contract, where we are storing the details of our RAG model. The PDF content attribute basically stores the chunks of input documents, and the embeddings are just vectors of floating point number. Now coming to the canister HTTPS module. Here we are doing canister HTTPS calls, and here I've mentioned the HPC node address for API calls. For each API call, we have to pay cycles, which is analogous to gas fee in other chains. Now I've come to the end of my presentation. Thank you for finding time for this.